Hi, I'm Ken from Orion Telescopes and Binoculars, and in this video I'm going to show you how to use the Orion Observer 2 70mm Equatorial Refractor. In the other video I showed you how to assemble it, so now that we've got it ready to go, now the next step is to take it outside at night and start viewing the sky. So let's get started. So the first step is to tell you what you've got, what you've purchased. This is a 70mm refractor, that's the diameter, 70 millimeters. It's got a 700mm telephoto lens, that's the focal length of the telescope, and that will tell you what the magnification is with any specific eyepiece that you put in. A 70mm like this can see the rings of Saturn, the moons around Jupiter, craters on the moon. It'll look like you're in orbit around the moon. And then it's bright enough to get into some of the brighter deep sky objects, so you can see the Orion Nebula with this, the Andromeda Galaxy, some of those larger star clusters and brighter things in the night sky. Let me tell you a little bit about the features and what comes with it, and then you'll be ready to start viewing the night sky. The telescope comes with two eyepieces, a low-power 25mm and a high-power 10mm eyepiece, and you get this 90-degree diagonal, so you're not craning your neck trying to look upwards into it. You look down comfortably into it this way. And there's a finder scope on the side to help aim the telescope. I showed you in the setup video how to align the finder, and just right here, since I'm at the eyepieces, I'll show you how to change the eyepieces. The 25 is your low power, and the 10mm is your high power. So you always start with your 25. You locate, let's just say you're looking at Jupiter here. You locate it with a 25, you focus it here to get a nice sharp image. And then when you want a closer view and to see the detail, you pull the eyepiece out, you drop the 10 in. Don't forget to tighten down the set screw on the side. I think when I was swapping them, I wasn't doing that, but you'll want to do that when you're using them in the night sky. Place the 10mm in, refocus, and now you've got a closer image and you can start seeing some of those fine details on the moon or the rings of Saturn. The telescope itself sits on top of the equatorial mount. Now, this mount is a little bit different than you might be used to with a photo tripod, which just moves left and right, up and down. This thing moves in these kind of funny arcs when you first look at it. It moves in this big arc along this circle, or this axis here. That's the right ascension axis. And then it also moves, that was east to west, that direction. And then it moves north to south along this axis. This is the declination axis. The reason they do that is so you can easily track an object in the night sky, because the Earth is a spinning top and Polaris is the axis of that point, and we're at some angle off to the side. So you've got to align this axis here with Earth's axis of rotation in order for it to track accurately. Now, how do you do that? That sounds fairly complicated. It actually really isn't. You just have to identify which direction is north and then what your latitude on Earth is. Now, you can find your latitude by looking at your smartphone or looking at a map. Here in the San Francisco Bay Area, we're at 37 degrees north latitude. So I think I've already preset it right here to 37 degrees. If you look in the setup video, I show you how to do that alignment. And just really quickly, if I was up a little bit further north, I would rotate the latitude scale up a little bit, and so now I'm probably at 40-something degrees, maybe up towards Oregon or higher, and then lock it back down. Then you just have to locate north. So either use your map or your compass, and don't use magnetic north, use true north. I happen to know that one of these streets out here runs exactly straight north-south, so I've already kind of pre-aligned it. This faces north, this axis, and then the latitude makes sure you're at the right height. You're basically pointing this right at the North Pole, at Polaris. Once you've done that, then you know that the sky moves around this axis right here. So let's say I'm going to loosen it up, and let's say the moon is right over there. So I lock it back down. I use the slow motion controls to fine-tune the position, maybe using the finder scope like I showed you before. Get the moon in the field of view. Now, as long as this axis is aligned and the equatorial mount is aligned, I just have to twist this one knob in one direction, and it will follow the moon or any other object in the sky all night long. It just pivots to follow along. Makes it really easy. That's the advantage of an equatorial mount. It allows you to just move it in one direction to follow those objects. The accessory tray down below the tripod comes with some cutouts, and they're designed for the eyepieces that you're not using at the moment. So here I'm using the 10mm. I'm pretending I'm looking at Jupiter there, and I have nothing to do with this eyepiece, so I'll just stick it down into the tray, and it's not going to fall out on you because it's captive. So just don't forget, when you swap eyepieces, put the one you're not using inside the hole so you don't drop it off the tray. It hits the ground and breaks. This telescope also comes with the MoonMap 260, which is a nice handy guide for identifying the craters on the moon. It's got the surface here, and then each individual crater marked out, including some Apollo landing sites, so it's a pretty cool map to have. And one of my favorite parts is there's two versions of this map. This is the correct image map if you had a reflector, and here on the back is the mirror image map if you have a refractor or a Cassegrain. So with this telescope and your 90-degree diagonal, you'll be using the mirror image map because it matches the view that you see through the telescope. All right, well, that wasn't so bad, right? It's a fairly easy telescope to use. With that knowledge that you've gained now, you're ready to start viewing the rings of Saturn, the cloud bands on Jupiter, see the individual craters on the moon. So enjoy your telescope. Thank you very much. Clear skies. Hi, I'm Ken from Orion Telescopes and Binoculars, and in this video I'm going to show you how to use the Orion Observer 2 70mm Equatorial Refractor. In the other video I showed you how to assemble it, so now that we've got it ready to go, now the next step is to take it outside at night and start viewing the sky. So let's get started. So the first step is to tell you what you've got, what you've purchased. This is a 70mm refractor, that's the diameter, 70 millimeters. It's got a 700mm telephoto lens, that's the focal length of the telescope.